Okay, so habang nagre-research kayo, no, ituloy muna natin. Baka mamaya nasa ano lang. Baka may parameters kasi sa default na naka-affect. So dito sa parameters natin, so titingin lang tayo. Kapag kinlik nyo itong antenna, you can select a different types of antennas like this, specifications in the database provided by the Cloud RF. So let's try to select one antenna and then you just click manage my antennas. So mag-open yung Cloud RF dito and login ka lang ulit. Punta ka sa My Antennas. Okay, pagka na-click nyo yung My Antennas, you will go into the database or the antenna database. Okay? Yan. So kapag nandito natin sa antenna database, you can select. Ang mostly na ginagamit ko is si CommScope. Yan. So si CommScope ang madalas. So depende sa ano nyo, sa favorite yung antenna. Ang favorite ko is si CommScope. Ito, 2,982 choices. So pagka-click mo si CommScope and then search, click search, lalabas yung different frequencies or different antenna specifications ni CommScope. Okay? So ngayon, nakikita natin yung ilan yung gain, antenna gain ni CommScope, yung antenna. And then ano yung lower frequency range and yung upper frequency range. Since we are using 2100 megahertz, okay lang, sige Sir Ronel, okay lang muna. Tuloy lang muna natin. Baka sa setup kasi nung ano, kapag fresh fresh na installation. Okay? So ito yung ating lower frequency range, 1710 up to 2690. So if you click this, makikita niyo yung kanyang radiation pattern. So this is the horizontal radiation pattern. So meaning it's top view. So nakatingin ka sa taas. So you can see the horizontal pattern. So this is a typical around 65 beam width, no, na antenna. And then meron siyang 17.54 na gain. And ito naman is yung vertical pattern. So yung vertical pattern, ito yung side view ng antenna mo. Pagka nakatingin ka dito sa gilid, okay? Pag nakatingin ka sa gilid ng antenna, okay, so nandito yun, parang ganyan siya, gumaganyan yan. Ito yun. Ito yung antenna na yun. Yan, gumaganon. Okay, so andito yung mga side lobes niyan. Ito naman yung top view. Ibig sabihin yung antenna mo nandito sa taas, so bumubuga siya ng pagganon. Okay? Ayan. Okay, so ito yung ating antennas. No? So pipili ka lang na isang antenna muna for the meantime. So once na na-click mo yan, pagpili ng antenna, i-heart mo lang siya. Pupusuan mo lang siya, no? Para mapunta siya sa iyong favorite. Okay, like for example, I will click this. So mag-heart siya. Ayun, meron na siyang heart. Okay? So nadadagdag na siya agad dito sa antenna pattern. Okay. So once na nakita mo na siya, nadagdag na yung antenna pattern mo dyan, mag-click ka dito, lalabas na yung antenna mo. Dito, lalabas na yung antenna mo dyan. Nakinlik, no, na hinart mo. So let's try one antenna. Okay. So let's see the frequency range para tama yung ano natin. So you can see here, 1710 to 26.9. Okay, antenna. And gain is 16.19. Okay, ayan. So ito yung antenna ang gagamitin natin for this, no? High band. So meron tayong vertical, meron tayong gain, and then yung azimuth natin, let's try naka 0 degrees lang. So ibig sabihin, yung azimuth ito, reference to the north or the 0 degree, you will orient your antenna 0 azimuth, 0 degree azimuth. And then meron tayong tilting. So yung tilting is ito yung tilting. Okay? So when you do the tilting, okay? When you do the tilting, kung ito yung antenna mo, ito yung pole ng antenna mo, no? And then, nakaganto yung antenna mo. Yan. Yan, nakayuko. Yan. So, meron kang tilting. So, ano itong tilting na to? Ano itong degrees na yan? So, yung antenna mo, nakayuko, no? Nakaganyan. Yan. Yan. Dito pala. Yan. Okay? Yan. So, ito yung antenna mo. Ito yung tilting. Ito yung degree na yun. Okay? Yan. Ano yung degree na yan? So, yun yung tilting. Okay? So, iyuyuko natin yung antenna natin. So, ang tilting na gagawin muna natin is typical na 2 degrees muna tayo. Okay? Naka 0 azimuth, 2 degrees tayo. Paano makapili ulit? Okay. So, kiklik nyo tong antenna na to. Manage my antennas. Pagka na-click nyo yung manage my antennas, punta lang kayo sa manage my antennas. Click nyo rin ulit to. Okay, ano? Ulitin natin. Click nyo itong manage my antennas. And then manage my antennas. Click. And then lalabas yung database. Antenna database. Okay? Once nandun na kayo sa antenna database, hanapin nyo si CommScope. Ito si CommScope 2982. Yan. Once na nahanap nyo na si CommScope, click search. Okay. Pag-click ng search, hanap lang kayo ng antenna na within 2100, no? Na nandun sa 2100 range. So 1710 to 2690 is within the antenna range. So para madagdag siya sa inyong database, i-click nyo lang itong favorite. Click yung heart. Okay. So i-click nyo lang yung heart. Ano na yun? Ayun, nag-heart na siya, no? Yan, nag-heart na siya. So andito na yung antenna na yun. So ito ay si VVPX3103. Okay. So kapag ino natin yan dito, lalabas na yan dito. Yung antenna nyo. Okay. Or kailangan nyo lang i-restart ulit yung system para mag-reflect yung antenna natin dito. CommScope. Ayan. So sa CommScope nandyan. Yan. So, click nyo lang yan dito. Pwede naman dito yan. No? So, pwede kayong maghanap dito. Yan. Yan. Pwede nyo gawin ganito rin. Pili na kayo na medyo magandang antenna. No? So, pangit yung mga pattern na ito. Ang kagandahan na kasi, no, kapag nandito ka na, is makikita mo agad yung antenna pattern. Yan. Okay. Papili lang kayo ng antenna dyan. So sa mga next sessions na tayo magpo-focus sa mga antenna specifications and properties. Yan. So once na nakapili kayo ng antenna, just add mo lang. Yan. Tapos okay. Yan. Tapos lalabas na dito yan. Okay. Lalabas na dapat dito sa antenna nyo. Pag-click ko ng management antenna sa home, ako punta. Kapag ka nagpunta ka sa home, punta ka lang dun sir sa sa antenna again. Kunyari andito ka, di ba? Pagpunta mo dito, teka, lalagout natin. Yan, pagpunta mo dito sa my account, punta ka sa my antennas. Ayan, dito ka sa my antennas. Pagka-click mo yan, doon ka na rin mapupunta sa antenna database. Okay, so kailangan nyo lang mag-login, logout, no? Yan. Para ma-open yung May ganung bug kasi si software eh. Yan. So minsan kapag may baguhin kang parameter, kailangan mo lang mag-login, logout. Okay. So na-set up na natin yung antennas natin. Naka 2 degrees na tayo and then 0 azimuth. Okay. And then after that, pupunta na tayo sa receiver or sa mobile. Yan. Sa receiver and mobile natin. So yung receiver natin, pwede natin mag-set ng coordinates pero di mo tayo mag-set. Antenna height nung ating mga receivers is typical naka 1 meter. Yan. Typical nasa bulsa lang yan, di ba? Kaya 1 meter. Antenna gain, di-default muna natin siya ng 0.1 dBi. Okay? And then gagamit tayo ng receive power, no? dBm. Yan, receive power muna yung gagamitin natin. Mamaya ni RSAP. Kasi medyo may konting calculation ng power kapag RSRP. So ito yung total RSSI muna kukumpitin natin. Okay? And then sensitivity level, papalitan natin to ng around neg 110 dBm. Ayan. So ito yung ating typical na pinakamahinang power muna, neg 110. Noise floor, i-default muna natin na 104. Okay? And then after that, pupunta tayo sa model. Yung model is the propagation model. Okay? Propagation model. So sa propagation model, if you remember the free space laws, okay? So meron tayong free space laws, and then if you try to make it what do you call this? Based on a certain area, based on a certain radio environment, so you will have a different types of model. Okay. So pagka kinlik nyo to, we will have a different model. So different frequency range. Meron tayong for VHF and UHF. Meron tayo for line of sight for microwave transmission. Meron tayo for Okumura-Hata from 150 megahertz up to 1,500. Typical, we use this for the GSM 900. We have the COS 231 Hata used for 1800. We also have the EGLI, and then meron tayo si Ericsson, Planet Earth, no? So ngayon gagamit natin si Lonely Rise because itong frequency na to is less than 20 gig. No, yung mga frequency range niya is less than 20 gig. Okay? And then reliability, default muna natin siya ng 95%. And then yung context natin is average. Okay? And average muna tayo. And then knife edge. So knife edge, ano yung nangyayari sa signal natin, sa electromagnetic energy natin when it bumps into an obstruction, no? So kumakalat sa gilid, no? Nag-knife edge refraction siya. So ganun ang gagawin yan. Profile, we will have minimal clutter muna just to show the simulation. And then yung optimization and then tuning ng tool sa na natin pag-uusapan, no? For this session, ang gagawin muna natin is to get familiar how the system or the software works. Land cover is enabled. So kung meron siyang building, okay, nababanggaan. And then custom clutter is disabled. Output, okay. So output is the settings where you want to set the resolution of your simulation. So meaning, if you set a lower resolution like 1 meter, so the pixel size is 1 meter by 1 meter. So that's how accurate the pixel size of your simulation. So the trade-off is it would take a lot of calculation time and CPU processing, CPU or memory. Okay. So typical, I use around 10 meters or 20 meters, okay, for this kind of exercises. So para optimal lang yung processing ng CPU natin. Hindi siya gumapang. And then, the color schema, you can choose different types of legend in terms of the signal coverage. So when you click here, there is a default values. Right now, I have used a lot of legends already. So when you look at this, I can just select, no? For example, ito. So lalabas na yung legend ko dito. Ito na yung signal level ko. So dito sa signal level that I used is neg 75, greater than neg 75 is colored blue, and then neg 80, neg 85, pababa. You can also change it to 2 values, like for example, the one that I prepared earlier, the LTE. Okay, for the LTE, I only have neg 75, which is blue, and neg 95, kung red na to. Okay, so I can see where is the high signal level and the low signal level. So para mas mabilis na maipakita. Okay, so later I will show you, no, kung paano yan. Radius indicates how far will be the calculation. So si ano kasi, no, si software can calculate up to 20 kilometers, but it would take a lot of time and processing time. So minsan ginagamit ko lang is nasa 5 kilometers to have an optimal calculation. Okay? So hanggang doon lang naman talaga minsan yung mga mga cell sites natin, 5 kilometers or 10 kilometers kung meron pang kung 900 megahertz na GSM. Pero this one, I just use 5 kilometers. You can set it up to 1 kilometer if you'd like, but for this exercise, we can set 5 kilometers. Okay, so you can use the engine that you will use is either your CPU or the GPU. So for me, I just set it to the CPU. Okay, ayan na. So we already have set our cell site using 2100 megahertz 40 watts LTE. Okay, ayan. Using the RSSI value. Okay, so ang gagawin lang natin is once it is set up, nakapili na tayo ng antenna, we will just click itong calculation. Okay, so when we click the calculation, you will see yung result ng ating simulation na matagal. No, calculating pa siya. No? Let's see. Ayaw niya ng ano, no? 2 kilometer. Okay, so 20 kilometer. Baguhin lang natin ang ano. 60 meter. Okay. Masyado malaki yung 5 kilometer niya. So nakita niyo, no? Sa 5 kilometer, ang laki na nung inaayos niya. Ayan. Okay. So meron tayong mga calculation adjustment. So basically what happened is like this. Ayan. Okay. So meron na tayong buga, no, ng simulation. Yan. So ganitong itsura kapag ang simulation natin is 2 colors lang. So let me show you kapag babaguhin natin yung kulay. Okay? Pag binago natin yung kulay natin, I'll use this parameter, ito. And then if you want to clear the layers, just click clear. Okay? Then after that, baguhin lang natin to ng 2 kilometers para mabilis. And calculate. Ganyan. Ganyan yung itsura niya. No? Yan. So within 2 kilometers lang. Yan, ito. 2 kilometers ang kinalculate niya. Pero if we want to extend to 5 kilometers, mag-i-extend yan. No? Lalayo yung calculation niya. Ayan. Okay, so mas lumayo yung calculation niya dito. Ito lang yung 2 kilometers kanina, pero meron tayong extension dito. Para lang maayos natin, i-recalculate lang ulit natin. Ayan. Ayan. So ito na itsura ng simulation natin. So this simulation is considering yung clutter, okay, na enabled natin yung building and using the calculation of power. Pero meron akong tinatroubleshoot dito kanina, no? Mali yung ano niya. Mali yung azimuth niya. Okay, so if you look at this, naka-ano siya, naka 70 degrees yung antenna niya. May typical naka 70 degrees, pero dito naka 0 ako eh. Hindi siya nag-aano, no? Hindi siya sumasama. So I think merong glitch do sa software niya. Pero anyway, ito yung sample, no, ng simulation tool. Okay? So ganun din kapag gumagamit tayo ng proprietary hardware, like for example sa mga operators natin, sa mga vendors, typical vendors. And if we use Open RAN hardware like COTS or GPP hardware like this, it would be same in terms of the radio network planning. Okay? And it would be the same also for like for example for different technologies. 2G, 3G, LTE, and 5G. That's why when we try to introduce, diba, yung radio access network, you will have different technologies, but the principle of the propagation, calculation of the link budget is the same. So you just have to consider some, of course, different technology. You will have to consider different parameters. But in terms of the path loss calculation, simulation, the principle is the same. Okay, so like for example for LTE, we just need to consider, for example, itong RSRP, no? So the reference signal power. Look at the difference in the RSSI and the RSRP, no? When we try to compare kapag RSRP. Kapag RSRP, ganito lumalabas, no? Yan, ganyan kahina yung RSRP natin. Okay? So meron siyang this one I'm not yet sure no kung saan part nagkaano no nagkatalo yung calculation nito. Kaya minsan hindi ko ginagamit muna tong RSRP sa ano sa mga demo. Mostly itong receive signal level pattern. Okay? Okay, so basically you have the ano, idea no. Yung ano no, yung ating um signal level. Okay, kung paano kayo maggagawa ng signal level, simulation ng signal level. And then later on, kapag pinagsama-sama natin yung mga use cases natin, you will appreciate how the mobile user is being transferred from one cell to another cell, how the LTE is doing the handover when we are doing the traffic steering, okay, and QoS prioritization, and what is the difference sa massive MIMO. So this is just a typical example nung ating simulation for visualization purposes. Okay? Yan, so you still have time no para pag-aralan yan. So probably after nung session natin, you can go try the different functionalities. Pwede niyo laruin yan, no? So but in the Asia Open RAN, we will have a separate session for radio access network planning. So the radio access network planning is included as one of the fundamental courses. So doon makikita niyo kung paano magana no. How to use different types of antenna, how to plan the frequency, how to plan the PCI. But for the meantime, this one I just shared with you how the typical simulation tools is used in radio access network planning. Okay? Sabi ni Ronel, di ko na po napalitan yung sa antenna. Lagi sa home po na pupunta. Okay, antenna, no? So, ano mo lang, i-restart mo lang, i-log out mo, and then para ma-refresh yan. Okay? Okay, so later magpapakita pa ako sa inyo ng isang simulation. So, this one is a typical example. I hope na nag-guess niyo itong pag-simulate ng coverage. So, using this tool, you can estimate, somewhat estimate what will be the signal level in a certain area. Like for example, sa mga use cases ng Open RAN system, if you want to provide coverage in a certain rural area with Open RAN system, you can see that you will only replace the hardware here. And some of the mechanisms like virtualization is almost the same will almost be the same as a typical na mga traditional networks natin. But the system becomes more intelligent. Later on, makikita niyo sa mga use cases natin. Okay? Okay, can I get a thumbs up? Kung pwede na tayo pumunta sa mga use cases. Okay. All right. Okay, so punta na tayo sa ating use cases. Okay. So now let's proceed with the use cases. Before for the use cases nga pala, no. So let's have some short discussion about the parameter and thresholds. Okay. So let's use this network now. Okay. Okay. So provided we have this site, and then another site is located here, and then I will name it as 2. Hold on. Meron tayo dito, isa. And then I will simulate. I'll do simulation. Okay. And then another site, probably here, na nakatutok ng 70 siya. 0 plus 70 will become, kung 0, nag-70 siya. Gawin natin 350. Natansya ko lang, no? para at least makita ko kung tama yung magiging simulation mo. Oops, sorry, nawala yung ano. Mhm. Mhm, mhm. Ito lang mahirap kay CloudRF, no? Medyo ano siya, complicated gamitin, unlike yung mga professional tools talaga na ginagamit sa telco. Hindi ka nakasunod sa teka. Pwede mo nang ma-review itong session natin. Teka, nagkamali na naman 'tong ano 'to. 270 andito na naman siya 'no. Palitan nga natin 'to. Ang hirap kasi dito hindi siya sumusunod sa ano, eh. Nagkakaroon ng bug yung ano, eh, antena, eh. Anyway, gagamit tayo ng isang tool 'no, 'wag 'tong si CloudRF. Pero itong si CloudRF is ano niyo, i-try niyo lang 'no, para at least meron kayong access sa mga simulation tools, okay? Okay. So itong isang tool na papakita ko is another one. Okay. So this one is another tool ng simulation. Okay. So what we are going to use in this tool is like for example itong si Smart or si Globe. Okay. I-move natin yung base station natin dito. Okay. And then meron tayong base station nandito. Kunyari lang to it's a typical example lang to. Okay. Okay. Ayan. Okay, so we have 3 samples ng simulations natin. And then I will do simulation. Okay, sabay-sabay natin siya i-simulate. Mas madali dito no kaysa kay CloudRF. Pero it works the same sa simulation. So let's just try to do simulation. So this one you can see the simulation is covered no, fully covered with the different colors. So when you look at the colors, nag-crash. Wait. Hold on. Bukusan ko lang ulit. Okay. Okay, punta tayo sa Tagaytay. Yan, nasa Tagaytay. Ayan. So, I'll recreate a site, ano? Yan, I'll recreate a site from 900, like for example, 900, para mas madali yung visualization. Okay? Okay, so we have a base station 1, and then another base station here. We'll create another base station with 900 sector. And another base station coming in this location. So this is just for the typical example na gagamitin natin all throughout. And then we will have the simulation. So for the simulation, we will just change the parameters. Okay, so gawin lang natin itong neg 70, okay, neg 80, neg 90, neg 100, neg 110, and neg 120. And then we'll change the color. Yan. So, para lang meron tayong may maganda tayong we have a good legend para sa exercise. Okay. Red and black. Okay. So once we have these 3 locations, okay, so we will have simulation. Yan. Yung ating simulation, ano. Yan. So covered, no? Kita nyo, 3 location lang very covered kasi 900 yung frequency natin. But if we change it to different frequency like for example, 2100, you can see the difference. No? You will see the difference. So dito makikita nyo na yung frequency has a great impact no sa coverage ng system natin. So this one looks different. No? Yan. So this is a typical example ng coverage simulation. So meaning in whatever location the subscriber is located, they will have neg 70 and above signal level. Okay, so this is what the simulation is showing. What we will do is we will have different type of simulation. Okay. Okay. So we will have this strongest server, best server. Okay. So kapag ka merong subscriber na nandito, for example, nandito yung isang subscriber, no? And then located probably with the, in between, no? Sa 6.5 dito, and then nasa 0.7, nasa gitna siya, no? So, sa palagay nyo, which cell site is serving the subscriber? Base station 001, 003, or 002? O, lagay natin sa gitna. Nandito siya. Okay? Ayan. So, nandito yung subscriber sa gitna. Ito na lang. Okay? Teka lang, ayusin natin. Ayan, nandito yung subscriber sa gitna. Tingnan, sino ang nag-reserve dito? Saan siya nakakonect na cell site? Kay base station 1, kay base station 2, or kay base station 3? Type nyo lang, base station 1, base station 2, or base station 3. Sa palagay nyo? Just hula lang. Just hula. Okay, base station 1, base station 1. Okay, so tatandaan nyo to, no? Itong area na to, no? Yan. So the best way to identify that is through the use of best server, no? Strongest server. Okay. So strongest server, even though we have full bars in the area, we have a best server. Okay. And the best server looks like this. Ayan. So makita nyo itong area na to. No? So it's a boundary between, ayusin natin yung ating i-high resolution natin para medyo mukhang kapanipaniwala ng konti. Yan. Okay. So you can see, no? There are areas, kunyari ito yung area natin, I'm in the boundary of cell ni base station 1 at cell ni base station 3. Nandito ako. So if I'm a subscriber na nasa gitna, so I will experience itong what we call the ping pong effect. Pabago-bago ako ng serving cell, no? So there's a possibility na ako ay magda-drop call. Yan. And look at this, no? Itong base station 2. Napakaliit ng ano niya, no? Napakaliit ng coverage niya compared kay base station 1 at base station 3. And meron siyang overshooting dito. Okay? So meron siyang portion na bakit siya nandito, no? So it should be ang dapat na gagawin natin is nandito lang siya. Nandito lang dapat yung coverage ni base station 2. We don't want na nag-overshoot yung isang cell. Okay? So, yun yung pinaka-purpose ng radio network planning and optimization, right? We want to have control sa ating coverage. Although RF is different to control, pero at least we have to manage yung mga serving cells niya. Like for example, ito. Okay? So, we can see, no, na meron tayong control. At least meron tayong certain coverage. Pero sa mga areas with overlapping sectors like this, okay, meron tayong mga ganyang klase, no, na mga cases. Okay? So what will happen is that, for example, one subscriber nasa biyahe siya, no? Tumatakbo siya dito. Okay? So right now, he or she is connected sa cell site 1. Example, no? Sa cell site 1. Okay, sector 1 ni base station 1. Napakita ko lang. So tumatakbo siya dito. Okay, so ano siya? And then after some time, kung pumunta siya sa boundary, magkakaroon ng measurement report. Okay, after the measurement report, kung masatisfy niya lahat ng requirement, it will be handed over to base station 3. Ang tawag natin is mobility. Okay, so meron siyang mobility. So feature yan ng cellular technology para tuloy-tuloy yung ating connection. Okay? So to manage this or to control this kind of mobility, meron tayong mga parameters and thresholds na ginagamit. Okay, so ito yung mag-uusapan natin, no, kung paano siya ginagawa. And this will be indicated also or discussed also in the Open RAN use cases. Okay. So typical when you are holding your phone, even though wala kayong ginagawa sa telepono, your phone is quite busy in monitoring different types of parameters. Okay? It is not resting. No? Kahit na naka-idle mode siya, kahit nasa bulsa nyo lang siya, it's in your pocket, it's still monitoring a lot of parameters. Okay? So when you look at when you connect your phone, yun ka lang ha. Bakit ayaw magana? Ay, kaya i-release ano ko lang. Naku, naghang yata ako. Hold on ha. Object 15. Object 15, slide 13. Okay. Nakulo na moment, no? Nangyari. Okay. So, even though you're not doing anything sa inyong phone, your phone is quite busy in monitoring different types of parameters and measuring different thresholds. Okay, like for example, no? In a simple speed test na ginagawa ng inyong telepono. So this is just a typical example of a speed test. Familiar naman kayo sa pag-speed test, pag-check ng speed. Punta lang kayo sa application ng Ookla and then you will monitor what is your speed, connection speed between sa server na to ni Smart. Okay, so it depends sa server na nakakonekta ka. So when you look at this, this phone is connected to a 5G network. Okay, so naka 5G tayo. Here in the Philippines, when we are connected sa 5G network, it means we are using NSA. So most of the time, it's NSA. So I'm not sure if meron na tayong SA, no, standalone na naka-deploy commercially sa Pilipinas. Pero most of the commercial 5G deployed in the Philippines is under NSA mode. Meaning there is a non-standalone, there is a your site is connected to the LTE core. The main node is LTE and the secondary node is 5G. So what happens is that your phone is monitoring two systems simultaneously. You can see here the parameter for the NR, the 5G. Okay, so you have the signal level. So this signal level bar, if it's full bar, you can see here the actual and the accurate value of that signal level. We call it the SSRSRP. In this case, it's neg 60 and above. Okay, and then you can monitor also the quality using the signal to interference noise ratio. You can see what band 78, what specific frequency, what is the bandwidth used, and different parameters. No? Ito pag-usapan sa radio network planning or sa RAN. No? Yeah. And at the same time, your phone is monitoring also LTE parameters. So you can see the frequency is different to the frequency used in the 5G. In the 5G, you are using 3500 megahertz or 3.5 gigahertz. In the LTE, you are using 150 ERCN equivalent to 2100 megahertz. Okay. And you can see also the throughput in different layers. Remember the different layers that we have in Open RAN, in the protocols. You have the RRC, okay, the PDCP, the RLC, the MAC, and the physical layer. Okay, so you can also monitor it here. What are the data flow? No? Ano yung mga throughput at each layer or protocol layer ng each system. Okay. So since this system is using a non-standalone mode, the bearer split, no, or the data split is happening in the PDCP layer of the NR. Okay? So hindi siya dumadaan sa PDCP ni LTE this time. Okay? So kaya wala siyang data. Okay? So later on yan, saan yan? sa ating run planning. Okay? And you can see also the different layer messages. Okay? If it's RRC connection reconfiguration or the radio bearer configuration, okay, the cell group configuration. So you can see what are the different events happening. Okay? Or different messages or task performing by your UE towards the network. Okay? So ito yung nakita natin sa ito yung talaga yung drive test tool. Okay? We call it a drive test tool. Okay? So diyan nakita natin yung mga different measurements. Okay? So nagmo-monitor siya. Okay? Bakit nagmo-monitor yung ating system, no? Like for example, in a typical 5G connection. Let's discuss no yung different the difference between the threshold, the hysteresis, and the time trigger. Okay. So this is a generic example to explain how the event threshold, hysteresis, and time to trigger together control the event triggering. So the event triggering is this is what happens no when, like for example, nagkaroon ka ng 5G, so there is a specific event that triggers that instance. So we'll talk about the event B1. Okay, so ito muna tayo sa event B1. So ang definition ng event B1 is the inter-radio access technology, meaning the other technology. So meaning if you are on the LTE and then you monitor the signal level ng 5G, that's IRAT because they are different radio access technology. Okay? So inter-radio access technology. Neighbor becomes better than the threshold. Okay? Neighbor yan and becomes better than the threshold. What do we mean by neighbor? Neighbor is the one that we define na sasalod sa ating mga current cells for mobility. No? Like for example, this cell, ang neighbor nito is itong kanyang mga sector, mga co-sectors. No? Tawag natin diyan is mga co-site neighbors. Okay? So ito, neighbor niya yan. Ito, neighbor niya yan. So para pagka naglalakad ka no sa paligid ng cell site mo, hindi ka mapuputol. You will be handed over to the different sectors of the same site. So that's the neighbor. And if you will go from one point to another point, there is also a neighbor. Okay? So inter-site neighbor naman ang tawag dito. Okay? Inter-site. So different site. If these two sites belong to one technology, like LTE, we call it intra. No? Intra technology, no? Intra. If these sites belongs to, like for example, LTE ito, and then this one is 3G, so we call it inter-RAT, inter-radio access technology. And then sometimes itong site na to also contains LTE, GSM, and 5G. So meaning yung mobility might be happening also sa the same site with different technology. So lumilipat ka lang ng layer. Pero nandun ka lang sa taas. So nandun ka lang sa isang site na yun, no? Sa physical site na yun. So doon nangyayari yung inter-RAT or intra-RAT, no? Or intercell, no? Okay, or inter-RAT handover. Okay? So ito yung explanation natin dun sa neighbor. Okay? So the event B1, which could be either SSRSRP and SSRSRQ. So meron siyang signal level. It's either triggered by the signal level, okay, or quality. Okay? So when you look at this table, you can see the different events, no, or scenarios, no? So values. So you have the signal level. Okay, so the y-axis is the SSRSRP or the RSRQ. So it's either the signal level or the quality. Okay. And then on the x-axis, you can see the time. Okay, time in either seconds. No? So you can see here 3 different terminologies like threshold, hysteresis, and time to trigger. So the threshold, it depends on the value of your signal level or quality. So let's just focus on the signal level first. So in the signal level, you will have what we call the leaving level, the threshold, and the entering level. And in between, we have the hysteresis. So yung hysteresis is parang margin. You know? We have this certain margin. Okay? So we have the lower hysteresis and the upper hysteresis. So when you, for example, pupasok ka sa isang, nasa kalsada ka, no? And then you enter a certain coverage area of a cell site. So your phone is continuously monitoring, no? Yung mga parameters na yan. Okay? You can also enter yung hysteresis, a lower hysteresis, but it will not trigger, no? Yung ating event. And then at a certain point in time na na-reach natin yung upper hysteresis, lumagpas na tayo sa upper hysteresis. So we are now entering what we so call the entering level. Okay? And then once na lumagpas na tayo sa hysteresis natin, sa upper hysteresis, doon na tayo mag-trigger ng time to trigger o orasan na niya yan. Okay? And then the time to trigger could be like, for example, nag-set ka ng trigger ng around 3 seconds or 5 seconds. Ibig sabihin, kung 5 seconds na for example, neg 100 dBm, yung signal level, no, okay, above the hysteresis na tayo. Kung 5 seconds na neg 100 dBm yan, okay, magte-trigger ako ng event ng B1. Okay, so mako-consider ko na event B1 yon. Pero dito, if it's less than the time to trigger, hindi niya i-trigger yan. So bumaba ulit yung signal level mo, and then habang naglalakad ka, pumasok ka ulit sa malakas sa signal level. Okay? So nag-start na naman yung timer natin. Okay? And then na-meet mo yung signal level and then yung time to trigger na 5 seconds. Okay, so doon ka papasok sa event B1. So sabihin ng sa'yo na monitor ng UE mo na okay, meron na satisfy natin yung threshold, and then yung hysteresis natin, and then yung time to trigger natin. Okay, so that's the time that you will eventually try to consider yung iyong 5G neighbor na pwedeng i-add as a secondary node. Okay, itong event B1. And suddenly kapag nawala ka sa signal level na yon, okay? So mag-start na naman siya mag-monitor. Okay? So meron pa rin tayong time to trigger. And then suddenly kung bumaba ka na ulit sa signal level, ibig sabihin lumalayo ka na doon sa cell site o nawala na yung signal level. So bibitawan ka na nung mawawala na yung measurement na yon. Okay? So there will be a report on leave, no? So the event is left when signal is below the leaving level continually for time to trigger. So ganun yung basics ng ng threshold, hysteresis, and time to trigger na makikita niyo dito. So kaya dito sa sample natin, I just make it a visual, no, para at least madali natin ma-visualize at ma-imagine. So meron tayong signal level dito. So as we go, as we move further dito sa base station 1 na to, so humihina yung signal level natin. And then while na humihina yung signal level natin, nagmo-monitor naman ng ibang cell yung ating mobile. So minomonitor niya to or minomonitor niya to. Okay? Kapag na-satisfy niya yung signal level requirement, threshold, and hysteresis, okay? So that's the time that it will execute yung handover. Either dito or dito. Okay? So ito yung importante mamaya sa pag-usapan natin sa use cases. Okay? Para pag pinag-usapan natin yung mga traffic steering, QoS, beam, grid of beams ng massive MIMO. No? Okay? Ayan. So ito yung ating parameters and thresholds na pag-uusapan. Okay? Okay. So probably medyo marami tayong pinag-usapan. Let's take a 5-minute break muna. Okay? And then pag-usapan natin yung mga use cases ng ORAN Alliance.